All right. It looks like we're going to have two different recordings here, and I obviously can't do this, stop it all the time like that. But that was important. That phone call was important, so I had to do that. However, let's get back to this. And of course, where are we? What would you think voltage at A is for this? And in fact, we already know that, don't we? Because we're expecting it to be 0.7071 times your source. So it should be 70.71. And let's look at that now. Let's look at at what the current is. We know what the total impedance is. We know what the voltage is that's coming out of there. So we can quickly figure out what the current is going to be through that at resonant, or at the value where the resistance of the resistor equals the reactance of the inductor. So the current through this circuit then is going to be 100 volts peak at 0 degrees divided by 7,071 ohms at an angle of 45 degrees. And I think everyone can see that we're going to get minus 45 degrees out of there. But what is 100 volts divided by 7,071 ohms? And that's going to be 14.14. Let's just write that down. 14.14 milliamps. And again, that'll be at minus 45 degrees, because 0 minus 45 gives me minus 45 degrees. So that's what my current is going to be. And now if I wanted to find the voltage drop across the resistor, I'm just going to put delta VR. That's going to be the current, 14.14 milliamps. And of course, at minus 45 degrees. And of course, remember that's milliamps, so we have to put that in really as 0.0141414. And then we've got to look at the resistance of that resistor, 5,000 ohms at 0 degrees. And that tells us, I'm just going to draw a line down here so that we can sort of separate out the various different things that we've been working on through this. And so we know that the voltage drop across the resistor for our, I'll call it resonant, for our resonant frequency. It's not resonant, of course, but you know what I mean. Is going to be 70.71 volts, right? That's what our voltage drop is going to be across this. Oh, actually, this is coming up from here, isn't it? So, oh, no, that's fine. Yeah, that's fine. My voltage drop at that, and then we got minus 45 plus 0 gives me minus 45 degrees. I think everybody's going to see what's really happening here, isn't it? 70.71 and minus 45. So what is my voltage at A then? In fact, why don't I write this out? Because if that's at 45, then really this is going to be, and I'll let you do this on your calculator yourself, but this is going to be 50 volts minus J 50 volts. How do I know that? Well, I know that the sine and the cosine of 45 degrees, negative 45 degrees, the cosine is 0.7071. The sine of negative 45 degrees is minus 0.7071, right? So we know that, and that's where I got this from. 0.7071 times 70, well, what is 70 times 70% of 70? Well, that's 50. Everybody knows that. And if you've been working with this long enough, it just comes to you. So there you go, 50 minus 50. So we know that we've got coming out of the source 100 plus J0, and then we want to subtract off that 50 minus J50 volts, right? So what that's going to give us is 50 minus 50. I'll do that one. That'll be 50. In fact, I'm doing them all really, aren't I? And then 50, or 0 minus a minus 50 gives me plus J 50, right? So we could write it like that, or we could write it as 70.71 at an angle of 40 plus 45 degrees, right? I'll put a plus in there. That's a plus. So yes, so we have 70.71 volts right at point A, just like I said that we were going to, and that's at the frequency at which the resistance in the resistor equals the reactance in the inductor. And so there you go. Now we've got the two of them. I think I did this backwards because I've really got the one way over here. This is, you know, for low frequency. And then we did the one for resonant frequency here. And it looks like we're going to have to do the one for high frequency over here. So this is going to be the high frequency one. And let's look at that, where this is going to create something that's very high. So why don't we look at it as something like, actually, let's see, what have we got here? What is the 2 pi 683? Let's make that 10,000 hertz. So at 10,000 hertz, now let's get a couple things here, because we know that omega at 10,000 hertz is going to be 62,830 radians per second, right? So 10,000 hertz, omega 62,830 radians per second. If I was to multiply that by 1, that would be 62,830 ohms. So let's write that. So I've got Z total for our circuit in the high frequency. Let's just write, you know, 10,000, keep that right there. That's going to be 5,000 ohms plus J 62,830 ohms, right? I think everybody can see what's going to happen. 62,830 squared, I'll do it, but 62,830 squared plus 5,000 squared equals, taken to the square root, 63,028. So I could say that my total impedance is 63,028 ohms at an angle. Now, this angle is just going to be so close to 90 degrees. I'm sure it's like 89 point something or other, but let me give you that. 62,830 divided by 5,000, and then take that quotient to the inverse tangent, and that gives me 85. Oh, wait a second. Yeah, I think it was 85 degrees. I'm going to have to do that again. 63,028 squared plus 5,000 squared. No, what? 62,830 divided by 5,000, and then take that quotient to the inverse tangent, gives me 85.45. 85.45. I'm sure you're all ahead of me on that one. So 63,000 at 85.45 degrees, then we can get our current, and I think everybody can see our current is going to be almost zero, right? Our current is going to be almost zero. So this one down here, that was like 12.47. Then here was 70.71 right there. They call these fine point. This is not a fine point. And then up here, we want to see what that is too. And so we've got the total. So the total is going to be 100 volts peak at 0 degrees. And I think everybody can see what's going to happen here is the current is going to be exceptionally small. So if I were to divide that by 63,028 ohms at an angle of 85.45 degrees, my current is going to be very, very, very low. I get 1.6 milliamps. 1.6 milliamps at an angle of minus 85.45 degrees. So you're thinking, well, that pretty much shows it, because if we've got almost 20 milliamps over here where we had it at a very low frequency, and we had 14.14 milliamps here where we had it at the what I'll call the resonant frequency, and I'm going to just break that down here, bring that down there. And then this is 1.6 milliamps. So it's going to be a very small current, and it's going to be a very small voltage drop, isn't it? Just like we saw in the reverse for the RC filter circuit. So if we've got that, then the voltage drop across the resistor, I think everybody can see, I'm just going to multiply 1.6 milliamps at minus 85 degrees by the resistance, which is 5,000. And that gives me 7.9 volts drop at an angle of minus 85.45 degrees. I left a step out there because I'm running out of room, but I think everybody can see, you know, what I do. I just multiplying the voltage drop is just I times the impedance of the resistor, which is 5,000 at an angle of 0. And so 0 plus minus 85.45 gives me that. And then I also have the 7.9, which is a very small voltage, but this voltage drop that we've got, very small at almost 90 degrees. So let's rewrite that voltage drop so that we can subtract it from 100 plus J0, right? So 7.9 times the cosine of 85.45. And why do I say 85.45? Because the cosine of minus 85.45 and positive 85.45 equals the same thing, doesn't it? So 7.9 times the cosine of that equals 6.623. So 0.623 minus J. Why do I have a minus there? Because it's minus 85.45, right? So 7.9 times minus 85.45 gives me minus 7.88. 7.88 volts. So, you know, if I have 100 minus that, so the voltage at A then is going to be 100 minus 0.623. And that's 99.38. And then 0 minus a minus is going to give me plus 7.88 volts. And you're probably thinking, well, God, that's going to be over 100. Yes, let's see. Let's square that 99.38 and then add to it 7.88 squared equals, taken to the square root, 99.7. Right, so it's going to give me 99.7, and then the angle that I'll have, I'll write that out just to finish us off. So this is 99.7 volts, very close to 100, right? There's the 100 that I've got there, 99.87 volts. And then my angle, and I think you're all going to see that it's going to be somewhere around 4.55, right? Should we write that down just to think? 4.55 degrees. I wonder if it will come out to that. So 7.88 divided by 99.38, and then take the inverse tangent of that, gives me 4.5 4. So I'm very close. But we know that it's really 4.55 because 90 minus 85.45 is going to give us that. Remember that became positive too. So that's what we've got. I think that this is going to be 2 because I had to break it at that one point, and I think that I actually stopped the first video. So I will make this an A and a B for lecture 9. All right, let's see if I can actually get my head. Hello, class. If I can actually get my head down here and turn this thing off now. Let's see. How?